Hey guys, welcome to my YouTube channel. So today we will be solving Leetcode weekly contest 363 fourth problem. Okay, pause the video, read the question, then I'll explain. Good. So what the question is saying that we are giving a one index array nums of n integers. Then it has defined a set of number is complete if the product of every pair of its elements is a perfect square. Okay, so what it is saying is if there is a set of numbers, just let me explain. So if there is a set of numbers 1 4 7 8 something like that, then this set will be complete if every pair, like that is every pair 1 into 4, 1 into 7, 1 into 8, similarly 4 into 7, 7 into 8, sorry, 4 into 8, and then finally 7 into 8. Each pair, the product of each pair should be a perfect square. Then it is called a complete set. That's the one thing that is defined over here. Now, the second thing it is saying that what is the element sum? Whatever the set we have. So let's say if we have a set consisting of I1, I2, Ik out of this 1 to n, then element sum is the value of nums of I1 plus nums of I2 dot 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 to nums of Ik. Basically, these are the indices we have taken considered in our set. Now, what the question is saying the return the maximum element sum of a complete set. So there are two things to note down here. First one is maximum element sum, and second one is complete subset. So basically, we already know what is the definition of complete subset, and we already know how to calculate the element sum. Now, how can we solve this problem? Okay, so if we'll go on thinking that let's say just forget everything and let's think over one thing. If we have any one number, sorry, if we have any given set, let's say a b c something like that, then we know that this a multiplied b should be a perfect square, let's say m square. Then a multiplied c should be equal to some perfect square, let's say n square. Similarly, b multiplied c should be equal to some k square. Now let's say if I take one number as 1, let's say I have considered as 1, then the next number what I can do is, if one number is 1, then for every number to be a perfect square, we can have a perfect square over here. So for every valid indices, like one square won't be valid because we won't take the same index twice. Because if you'll notice over here that we are taking subset from 1 to n, that are the indices. So 1 cannot be repeated. That's why we can start from 2. So we can put over here 2 square, 3 square, 4 square till the moment this is less than equal to n. Remember, listen carefully what I'm trying to say. So if I want 1 to be one element, then all the other elements should be a perfect square. Now, if if I take 2 square over here and 3 square over here, I will also have to, like, till now we have considered everything with 1 and it's a perfect square. But we also have to make sure that the other pairs are also perfect square. So if you will see carefully, what we are getting is two perfect square. Let's say a square and then b square. Then obviously these can be written as a b ka whole square. Yeah. Okay, so what I'm saying is if we'll check one and then every other perfect square number, a square, something like this, b square, c square, then every possible pair, either you take it to one or you take it to any two different numbers, then every time you'll have a perfect square. Okay, I hope that's clear for one. Similarly, if we consider 2, then the next number, what can we put over here? So what we want is to multiply something is equals to of the form 2, sorry, m square. Now I know that m square can either be something like prime number, m can be prime number, or what we can do is m can be some composite number, let's say 8, and that can be represented as 2 into some d squares. So what we realize, if we have numbers of the form 2 into d square, then if we'll multiply it with 2, we can write it as 2d whole square. Okay, so what we need over here is 2d square. Now again, we'll have to figure out what are the values we can put over here. So for 2, we can put if we will take d as 2, okay, so then it will become 8. Then if we will put do d equals to 3, then it will become 18. Now one thing to notice is if we consider 2, 8 and 18, because we already know that for every pair with 2 it will be a perfect square because 2 will be common out and d square was already a square. But if we will take something like 8 and 18, 8 and 18 can also be written as 2 into a square and 2 into b square. Again, if we will multiply this, it will become something like 2 into a into b whole square. Okay, so I hope this concept will be clear that for every number, let's say for 1, we can go with something like this a square, b squared till it is less than equal to n. For 2, we can go with 2a square, 2b square, and here a square will be something like that 2 square, then 3 square, then 4 square. Okay, or we can, if you want, we can write down it as something like this 1 into 1 square, 1 into 2 square, 1 into 3 square, and then this series can be continued as 2 into 1 square, 2 into 2 square, 2 into 3 square. Okay, so now we just have to, now we have all the possible sets, and also why we are taking all the possible sets, if you'll see the numbers are always positive, so we can take as many as elements if they're possible from the set. So let's say if in set there were 4 numbers 1 2 3 4, then we can, if we want maximum sum of these elements, then we can simply sum all the elements, that is nums of index 1 plus nums of index 2, something like that, so that the element sum will be maximum. Okay, so till now what we have established, we have all the possible sets saying that if we'll start with 1, we'll have one set, if we'll start with 2, we'll have another set, if we'll start with 3, we'll have another set. Now, do we need to start with 4? Think it. No, because we have already considered 4 over here. So we will also have to take in account that the numbers we have already taken should not be repeated. Okay. So what we can do, we can maintain some set or anything as per our according convenience to mark it as visited. Okay. So now what the solution is became, if I have this subset like 1 and a square, then b square, something like that, then for all the indices, I can calculate the sum, and for this one particular subset, I can have sum 1. Then for another subset like 2 into 2a square, 2b square, something like that, I can have sum s2. For all the possible subsets, I will have to find the maximum of, that is maximum of s1 comma s2 comma dot 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 sn. Okay, and that will be our answer. I hope this approach will be clear. Let's move to the solution. So first of all, we have make a set just to mark it whether a number is visited or like taken already or not. Now, initially our answer was 0 and we have calculated the size of nums, that is n. Now, if we will take 1, then we know that the next number should be 1 into sorry, the next number we can start from here is the series should go something like that 1 into 1 square, 1 into 2 square, something like that, 1 into 1 square, 1 into 2 square, 1 into 3 square, something like that. So, and when up to we can go till the moment j into I is less than equal to n. Okay, so we start this loop. We take the sum of all the elements, and remember that these we are considering the indexes on one based index. So we are just subtracting one when taking the sum from the num from of the element of the nums. Okay, and then pushing this particular index so that we do not start from here. That's why we are also checking if the count of I is greater than 0, then we will just continue because we have already taken once and we don't need to repeat this calculation. Okay, so and after this one particular loop, we have answer is equal to max of answer comma cur, and then we can simply return our answer. Let's test the solution. And yeah, it's AC solution. Let me know in the comment section if you guys have any doubts. Thank you.